Let's say equation of a transverse wave. We are interested in mathematical model of wave, the way information propagates. We need to define displacement of a given particle at a given time from its mean position, transverse displacement. And this information, if it is present with us, then that is called equation. You will understand it. Look here. Let's say we have a rope and we will take along the length of the rope our x-axis. This is also the x-axis. This end, we'll call it source. We have been given that this source is executing simple harmonic motion along the y-axis. Let's define its motion over here. This source is executing simple harmonic motion like this. Remember, all this is happening along one line only, like this. It goes up, it comes back down, moves towards negative amplitude, and then comes back at the mean position and repeats its motion again and again. So this source, it is moving like this. It is executing simple harmonic motion. And information for source is known. We have been told that source is executing simple harmonic motion, let's say, according to this formula, which you know is the equation of simple harmonic motion. Y equals to A sine omega t. Normally you write x equals to A sine omega t because we say that things are executing simple harmonic motion in this direction. But for the given case, this source is oscillating along the y-axis, and therefore y equals to A sine omega t. This is for the source. And this information is known. When I say known, it means what? If I ask you, where is the source when time is 0? Put t equals to 0 and you find that y is coming 0, that means source is over here, shown with this point. When this small t, it becomes t by 4, capital T by 4. Omega t will become 90, sine 90 is 1. You know that y will become capital A. That means when small t is capital T by 4, source is at the amplitude. When small t becomes capital T by 2, omega t, it becomes pi, 180, sine 180 is 0. It comes back at the mean position, and then you can continue putting value of t, and you will find y, which is the position of source with respect to its mean position. This is the mean position. It is oscillating about this mean position. This information is known for the source. Everything is known. We have the omega. Omega is 2 pi upon t. Capital T is the time period and all. Now, we have been given this information that wave is traveling in this direction with velocity v. This is wave velocity. Now, what is moving in this direction? That is information. What do you mean by information? We'll see that. Information is traveling in this direction. Whatever command is given at this position, it travels in this direction. Which means if you say that this particle is at origin or at the mean position and is going up, then this information being at mean position and is going up is passed on in this direction along the x-axis. Different particles, once this information reaches a particular position, they will be at their mean position, respective mean position, and then they will move towards the positive amplitude. So, when let's say this one is at the amplitude, when source is at the amplitude, this is the information. That source is at the amplitude. Now, this information will move in this direction with velocity v. When it reaches some point, that particle will be at its amplitude. And then this information will keep on moving along the x-axis with velocity v. Now, what we found that after some time, this rope, its shape is like this. Let's say this is the shape of the rope at some time t. This is shape of the rope at time t. Shape of rope means this particle is at the mean position. This particle you saw is at the amplitude. This one is at the mean position. This particle is at the negative amplitude. This one is at its mean position. This is the shape, and this shape keeps on changing. How does it change? We'll see that. But the aim, when you say equation of a transverse wave, it means what? At a distance of x from the source, we have a particle, and we found that this particle is over here. This height is y, which means a particle at a distance of x from the source is found at a transverse displacement of y from its mean position at some time t. And we need to find this y as a function of x and t. This is called equation of a transverse wave. What does it mean? Transverse displacement of a particle from its mean position. Which particle? A particle whose distance from the source is x. At what time we need this transverse displacement? At some random time t. If we have this information, then by simply putting value of x and t, we can get transverse displacement of any particle which is present on this rope. This is called equation of a transverse wave. Write down this statement. Equation of transverse wave means transverse displacement of any particle from its mean position from its mean position at time t, at time t, and mean position of this particle, and mean position of this particle is at a distance of x from the source, is at a distance of x from the source. What is x? X is not the distance of particle from the source. Remember, suppose at some point you found that this is source, this is the particle. Then what is the distance between source and particle? Root over x square plus y square. We're not interested in that. We are interested in y. What is y? Transverse displacement of a particle whose mean position, this is the mean position, this mean position is at a distance of x from the mean position of source. You can modify the statement from the mean position of source at time t. That is called equation of a wave. And our aim is to develop this thing. And we have been told that everything about source is known. If somebody says find out transverse displacement of source at 8 seconds. At what time? 8 seconds. You just need to put t as 8. If somebody says find out transverse displacement when time is 24 seconds, simply need to put t as what? 24. Everything for the source is known. But we have no idea for this, and we want to establish a result for this particle. That will be called the equation. I hope you understand the meaning of equation. Now, let's develop this equation. Now, information I told you is moving in this direction with a constant velocity of v. V is wave velocity, and you will see later that it depends on the tension force in the rope. If you say that tension force is same everywhere, then v is constant. We are treating that velocity of wave along the length of the rope is throughout constant. Which means for information to reach this position from source, how long will it take? Let's say it takes delta t time for the information to reach this position from the source. What is the distance it has to travel? X. With what velocity? V. And therefore delta t is simply x upon v. Distance divided by velocity. What is traveling in this direction? Suppose, let's talk about sound, although sound is longitudinal, but for the understanding, we can use example. Suppose somebody standing at this point says hello. Now this hello is traveling in this direction. With what? V. That will be called velocity of sound wave. So, if you say hello is moving in this direction with V, how long will it take to travel a distance of x? You will say distance divided by velocity of sound. That means information reaches this point from this point after a time interval of delta t. Write down what delta t is. Delta t is time. Delta t is time taken by the information. Delta t is time taken by the information to reach position P. Let's call it P. And let's call the source position as origin or O. Position of source, mean position of source is O. Mean position of this particle, which is at a distance of x, is what? P. Delta t is time. Delta t is time taken by the information to reach point P from O. Then we can say that, then we can say that, now is coming the important part, we can say that information which is present at P, information which is present at P at time t, small t, information which is present at P at time t was present at O, was present at O when time was t minus delta t, when time was t minus delta t. We just need to understand this statement, and then we will have the equation of transverse wave. What information I have given to you? Look here. What I'm saying is information which is present at P. That information is what? Transverse displacement. Transverse displacement y at P at time t. Transverse displacement of this particle P at what time t is same as the transverse displacement which was present at O, at the source, but at what time? At t minus delta t. T minus delta t. That's the statement which you have just written. Transverse displacement which is present at point P at some time t. This same transverse displacement was present at O. But at what time? T minus delta t. What does it mean? Suppose somebody says hello at this point. Forget the whole thing in this form. A person standing at O says hello. This hello, let's say it takes 4 seconds to reach this point 4 P. After 4 seconds you found that hello is present at P. Now if I ask you at t equals to 4, what sound is heard by someone who is standing at P? You will say hello. He says hello at t equals to 0. It takes 4 seconds to reach this point. At 4 seconds, P, he listens what? Hello. Now, this says hello at P at 4 seconds is the same sound which was produced at O, but at what time? At what time? At 4 seconds. We are discussing at 4 seconds, and sound took 4 seconds to reach this point. 4 minus 4 is what? 0. This hello was produced at source at what time? 0. Hello at P at 4 seconds is the same hello which was present at source, but at what time? 0 seconds. We have the idea of source. Everything about source is known, and therefore now we have the idea of y of P at time t. Now y of a particle P at time t is simply what? Y, and therefore this y is y at O, but at this time. For source everything is known, and you will say A sine omega t minus delta t. It will take a few seconds for you to grasp the whole thing, but don't you worry, ultimately you will. This is called equation of a transverse wave. What is this? This is y of a particle which is at a distance of x. Where is x present in this equation? This x is present in this equation in this form. This is a sine omega t minus delta t. What is delta t? Delta t is x upon v. Delta t is x upon v. Y of a particle which is present at x at time t is given by this equation, which is called equation of a transverse wave. Let's verify this equation. If you say that this equation gives transverse displacement of each and every particle at any time t, let's say if you ask this equation, what is transverse displacement of source? What is the distance of source from the source? 0. This thing becomes what? 0. And you get what? A sine omega t. A sine omega t. Now, to understand this part, let's take a simple example over here so that you understand this part. Let's say this is your source. And this is the particle P. Now remember, source is at O. S for source, O for origin. Source is present at origin. Information is traveling from this point to this point. And let's take the example of sound again. Somebody told you that sound takes 4 seconds to reach point P from O. 4 seconds. This 4 seconds for you is what? Delta T. Now, suppose this is what? Mean position. Let's define this path in this form. This command, what is the command? Source is at the mean position and is going for positive amplitude. Let's call it A. When I say A, it means what? A means source is at mean position and is going for amplitude, positive amplitude. Let's say this point, this information, this command, let's give it a name B. What is B? B means source is at the positive amplitude. When source is at this point, let's call it C. This is what C. What is C? Source is at the mean position, but is going for negative amplitude. A is also mean position, but source is going for positive amplitude. C is mean position, but source is going for negative amplitude. This point is what? Normally you would say D. No, it's not D. What is this? This is source is at mean position and it's executing what? Simple harmonic motion, and therefore it is going for positive amplitude, and therefore this command is again what? A. Source is at mean position, is going for positive amplitude A. At the amplitude B. Mean position but is going for negative amplitude C. Is at this position. Let's call this position D. What is D? Source is at the negative amplitude. And then when it comes back at this point, it is at mean position and is going for positive amplitude, which is same as this. So these are the commands or the information, and this information is traveling in this direction. This is something like hello, which I said previously. Now, time interval between these commands you can see in this setup is T by 4 between A and B. Source will take what time to reach from A to B command? T by 4. B to C again T by 4. C to D T by 4. D to A T by 4. One oscillation is complete. T by 4, T by 4, T by 4, T by 4. 4 T by 4, that is one oscillation is complete. So remember, what is T by 4? T by 4 is time interval between these two commands. Now let's say this T by 4 for the case which we are having over here is 1 second. Remember, we're just taking an example just so that you can understand the meaning of transverse equation. T by 4 is what? 1 second. Now look over here. This is source at t equals to 0. When time is what? 0. Source says A. What is A? I am at the mean position and I am going for positive amplitude. This source at t equals to 0, it says A. Source at t equals to 0 says A. This is something which is known. Now, this A will travel in this direction and it will reach P after 4 seconds. After 4 seconds, sound is traveling in this direction with velocity so that distance from O to P is covered in 4 seconds, which is delta T. That means if you ask P what sound is heard at T when T is 0, the answer will be none. Why? Because at T0, A is first time sent in this direction. It reaches this point at what time? 4 seconds. So, when time at the location of P is what? 4, it will receive this information A, which was sent 4 seconds earlier. Now, let's go for B. This B, when time is 1 second, from this to this, when time is 1 second, source says B. That means I am now at the positive amplitude and this information now travels in this direction. It will take another 4 seconds and therefore by the time it reaches P, time will be what? 5 seconds, and at 5 seconds this P will receive this information B. Now look at the whole setup. If I ask you what is information present at P, information present at P at 5 seconds, at this time 5 seconds, then you will say that information which is present at P when time is 5 seconds was present at the source when time was 5 minus 4 seconds. It took 4 seconds for sound to reach this point B, and therefore you will say that information which is present at this position at 5 seconds, 5 was present at source at 5 minus 4. This is written 5 minus 4. So if somebody asks you what is sound heard by P, what is sound heard by P when time is 6 seconds? If I ask you this, what is sound heard by P when time is what? 6 seconds, you will say that this sound which is present at P at 6 seconds should have been present at O at what time? 6 minus 4. That means at T equals to 2 seconds. Now at 2 seconds, what source says? You already know that. This information is known. This is 0 second. This is 1 second. This is what? 2 seconds. So at 2 seconds, source says, I am at the mean position and I am going for negative amplitude, which for you is what? C. So you know at t equals 2 seconds, source says what? C. But you wanted this information at P when time was 6 seconds, and therefore you will say that this information is also C. I hope you now understand meaning of this line. And therefore, this equation now tells us what? We need at 6 seconds what is present at P. At 6 seconds, we need what is present at P. We have no idea for that, and therefore we ask this equation. What we ask this equation that tell us what is information if I say that time is t minus delta t. T minus delta t. I hope you understand meaning of transverse equation. Don't forget to note down this chart as a separate side note. Note down everything. Now look at this setup. Suppose we have these particles located at special positions in this form. I've aligned these points with this, the peak, this point, this, and this. And you will understand the whole concept. This is source. When time is zero, what is the command present at this point? Source. It says A. Command present at this point is A. Sound has not reached these points. And one important thing, it takes 1 second for sound to travel distance between any adjacent points. Let's take like this in this particular setup. That means sound will take 1 second to reach this point. From this to this, again 1 second. From this to this, 1 second. This to this, 1 second. All these points are equally separated. 1 second, 1 second, 1 second, 1 second. So at t equals to 0, we know what source is going to say. Source says A. No sound has reached these positions. When t is 1 second, you know that source is going to say B, t by 4. Source says B. That means at the position of source, the particle is at its amplitude. B means particle is at the positive amplitude. This is B. But this A, it is moving in this direction with velocity V, velocity of sound, and it takes 1 second to reach this point. That means this A, which was present at source when time was 0, after 1 second reaches this position, and therefore this second particle, information present at this particle is what? A. What is happening? If you look at this row at t equals to 1 second, then particle which is present at the source is at its positive amplitude, whereas this particle is at the mean position. Now, when time is 2 seconds, when time is 2 seconds, you know that source is going to say C. 1 second, 1 second. Source is going to say C. What about this one? You know that it's going to hear B. What about this one? You know that it's going to hear A. Source is at mean position and is going for negative amplitude. Is going for negative amplitude. This particle is now at the positive amplitude. This B, after 1 second, it reaches this position. Now this A, after 1 second, it reaches this position. That means this particle is at the mean position now and is going for positive amplitude. When time is 3 seconds, source is at D. Source is at D. This is what C, this is what B, and this is what A. C, it reaches this position. B, it reaches this position. A, it reaches this position. When time is 4 seconds, time is 4, source is again at mean position, has completed one oscillation and is going for positive amplitude. It says A. D reaches this position. C reaches this position. B reaches this position. A reaches this position. So when time is 4 seconds, source is at mean position and is going for positive amplitude. This particle is also at mean position and is going for positive amplitude. A, it means they both are in same phase. Phase of this position and phase of this position is what? Same. They both are at mean position and are going for positive amplitude. Phase of this and this, it's not same. This one is at mean position going for positive amplitude. This one is at the negative amplitude. So, what is the closest distance between 2 points which are oscillating in same phase? If I ask you this, then distance between 2 points, minimum distance between 2 points which are oscillating in same phase is called wavelength. Write down the statement. Minimum distance between 2 points, oscillating in same phase is called wavelength. Now, what is wavelength? Wavelength is given by lambda. This lambda is your wavelength. And what is wavelength? Wavelength is simply what? Distance. And what is distance? Distance is speed multiplied by time. Information is traveling in this direction with what velocity? V. We need distance. Distance is what? Velocity multiplied by time. Now what time it took for wave to reach this position from this position? 1 second, 1 second, 1 second, 1 second. That is what? One complete oscillation, which is what? Capital T. This is T0. This is T0. T equals to 1 stands for T by 4. T equals to 2 stands for 2T by 4. T equals to 3 is 3t by 4, and finally t equals to 4 is 4t by 4, which is capital T. So information takes capital T time to reach this point, which means distance is what? Speed multiplied by time. What is the time? Capital T. This is the formula for wavelength. What is wavelength? Minimum distance between two points which are oscillating in same phase, which is shown in this figure. This whole length from here to here, this is called lambda. When I say points or particles separated by wavelength lambda are oscillating in same phase, it means this. If you have two particles like this, then they are oscillating in this form. You will find that their motion is exactly same. They both are at the beam position, they both reach amplitudes, positive amplitude simultaneously, mean position, negative amplitude. They are always oscillating in same phase. Minimum distance between these two is lambda, and information travels in this direction with velocity v, and it took it what time? Capital T. 4 and 4 cancel. It took it capital T time, and therefore lambda becomes v into t. Now you know that what is t? T is 1 upon frequency. T is 1 upon frequency, and this gives us v as f lambda, a standard formula which I hope everybody has seen. V is what? F lambda, where f is frequency, natural frequency. Its unit is what? Hertz, or 1 upon second. Now, this is the origin of wavelength. Once you say particles separated by lambda, I said minimum distance. What do I mean by minimum distance? If you look at this row, then it will look like this. Let's say at some point you found that rope is in this form. This and this and this and this, they all are oscillating in same phase. Lambda, 2 lambda, 3 lambda. Now, it's not about this and this. It's about any two particles separated by lambda. Look at this particle. It's at the positive amplitude. This one is also at the positive amplitude. They will be oscillating like this. Look at this and this. They are both at negative amplitude right now. They will be oscillating like this. So separation between any two particles separated by a distance of lambda. If the separation is lambda, minimum separation, then they will be oscillating in same phase. This is also lambda. And now you also know why did I say minimum separation? Because if you say that separation between two particles is n lambda, where n is an integer, then they will be oscillating in same phase. Lambda, between this and this, 2 lambda, between this and this, 3 lambda. This and this, lambda, this and this, 2 lambda. Write down the statement. If separation between any two particles is n lambda, if separation between any two particles is n lambda, then where n is an integer, then they always oscillate in same phase. Then they always oscillate in same phase. Note down this. When you draw this information, don't forget to align these points accordingly as I shown in the figure. This with this, peak with this position is this, negative amplitude is this, and this position is Yes, draw the whole thing, especially this chart. Now let's look at the equation of transverse wave again, and let's see how we can arrange all those terms. We got the equation as y equals to a sine omega t minus x upon v. This is one for. You can also arrange all these things like this. A sine multiply omega inside. This is omega t minus omega x upon v. Look at this part, omega upon v. Omega upon v. What is omega? Omega is 2 pi upon t. And you already have v. And what is v into t? V into t is lambda. So this thing becomes 2 pi upon lambda. This 2 pi upon lambda is called k, and this is called angular wave number. Angular wave number. Two pi upon lambda. Because of 2 pi you call it angular. 1 upon lambda means wave number. If you simply write 1 upon lambda, then it is called wave number. Why do we call 1 by lambda as wave number? Look, this is called one complete wave. You have one wave in what length? Lambda. So you say that in lambda length, how many waves are present? One wave. Just for your understanding, in length lambda, how many waves are present? One. And therefore, in unit length, how many waves are present? You will say 1 by lambda. Number of waves present in unit length. Number of waves present in unit length is called wave number. If you wish, you can write down the statement. Number of waves present in unit length is called wave number. In lambda length, you have got one wave. If you draw it like this, and then this, you say that what is the total length? 2 lambda. In 2 lambda length, how many waves are present? 2 waves are present. So in lambda length, 1 wave is present. In unit length, 1 upon lambda. This is called wave number. When we use 2 pi, we call it angular wave number. So this is your 2 pi upon lambda, which is called k. When you write 2 pi upon lambda as k, what is 2 pi upon lambda? Omega upon v. And therefore this equation, it takes this form. Y equals to a sine omega t minus kx. Omega t minus kx. Omega upon v, it becomes what? K, and therefore a sine omega t minus kx. In some books, in school and all, they might give you kx minus omega t. It doesn't matter. If they write kx minus omega t also, it doesn't matter. Why? Because when you say that this is A, what is A? Amplitude. You can also write minus A. If you say this is A and somebody writes minus A, then that means what? Amplitude basically is what? A. If someone uses minus A over here, you can take the negative sign inside. Once you take negative sign inside, you know that with sine you can always take negative sign inside. Once it goes inside, it will be what? Kx minus omega t. You don't have to worry about that. Remember this second part is y equals to a sine omega t minus kx. What is omega? Angular frequency. What is k? Angular wave number. So again, what is omega? Omega is 2 pi f. What is f? F is frequency. What do you mean by frequency? Frequency is number of waves in 1 second. How many waves you have, how many oscillations you have in 1 second, that number is called what? F. This F is what? Frequency. When you have 2 pi, this is called angular frequency. What is frequency? Number of waves present in 1 second. What is 1 upon lambda? Wave number. What is that? Number of waves present in unit length or in 1 meter. In 1 meter, how many waves are present? 1 by lambda. In 1 second, how many waves are present? 1 upon capital T. In capital T time, in capital T time, how many waves are present? 1. In unit time, how many waves are present? 1 by T. This 1 by T is called what? Frequency. And when you use 2 pi upon T, when you use 2 pi upon T, this 2 pi upon T is called what? Angular frequency. So this K is your angular wave number. And this is another form of writing transverse wave. Put on this much.